Ya Pak Usman di rumah nih. Ya Pak Usman. Oh, nggak bisa ya, di mute ya. Oke. Jadi ada Pak Yusi. Oh,
Oke, Pak, siapa?
oke.
Siapa?
Gimana tadi tamunya?
Iya, Pak. Jadi nampaknya juga antusias diskusinya, Pak Jarod, karena mereka melihat prospek dari reaktor riset. Sebetulnya pertanyaan Pak Jarod tadi cukup ini sih, Pak. Cukup mereka mereka berpikir kenapa orang ragu dengan reaktor riset itu. Pada buat mereka hitung-hitungannya sudah jelas beruntung Pak Jarod.
Oh, iya.
Dan pastinya bahwa Kijang itu kan komersial ya Pak ya. Seperti halnya Jepang dengan yang baru itu sudah hitung-hitungannya tidak akan membuat mereka rugi gitu loh Pak Jarod. Pasti untung Pak Jarod. Karena saya melihat kalau apalagi dimuati dengan silikon Pak Jarod, itu pasti untung itu. Itu pasti.
Ya sih, muka-muka lah ada jalan keluar. Good afternoon, from colleague from Kepco ENC. How are you? So how are you?
How are you? Fine. Fine.
Well,
How are you?
well, so how many person would like to give the presentation for today? Can you hear me?
Yes.
Okay.
화면 공유를 해줘야 돼.
화면 공유를?
아니, 그게 아니고. 수준인데.
화면이 작아졌어. 키워서. 보고 연출 맞습니다.
Okay. We still have time for 4 minutes. Yeah, I think it's okay. How about the audio? Can you test your audio so the audience can hear?
Is my voice clear?
Yes, that's clear. Thank you.
Yes, it's clear.
Yeah. Okay. We still have 4 minutes before we start the webinar. So what time is it in Daejeon? Almost 6 o'clock? 6
Almost
p.m.
6 o'clock here.
Oh, okay. Yeah.
Yeah.
We are ready.
Please wait. We will start at 4 o'clock Jakarta time because we are waiting the chairman of Indonesian Nuclear Society. Usually open the meeting and then we can start the webinar. I'm expecting he will come soon in this webinar. Wait.
Yep.
Oh, he's not in here. He's not in this meeting. Please wait. We still have 2 minutes before we start. He's already here, Professor Susilo, but it seems to me his microphone has trouble. Pak Susilo sudah siap? Ya, Pak Susilo ini.
Bapak suaranya nggak bagus.
Ya.
저 금상 건물 안에 사는.
Okay, I will start the meeting. I will speak first in Bahasa Indonesia, then we can speak in English. I would like to mute all of the participants first. Selamat sore, Bapak Ibu sekalian. Kita memasuki webinar ke-6 tahun ini. Jadi kita di penghujung bulan Februari, ternyata cepat sekali. Kalau sudah tua itu bulannya itu penghujung itu sudah menjelang Maret gitu kan. Nah, untuk sore ini kita mengambil tema yaitu teknologi BANDI dari Korea Selatan yang menjadi salah satu ujung depan setelah smart. Mereka pernah meluncurkan SMR Smart. Mereka juga punya beberapa teknologi di large reaktor atau PLTN yang besar yang sudah dibangun di Uni Emirat Arab juga. Nah, ini adalah kelanjutan kerjasama HIMNI dengan asosiasi nuklir di Korea. Ladies and gentlemen, today we have a special webinar because we have a guest from the Kepco ENC. This is the continuation of the Ikonsa 2023 last year. We invited the speaker from Kepco. He speak about the BANDI, one of the innovative small modular reactor from South Korea. Hopefully we can listen, we can learn from our counterpart from Kepco and ENC about this technology, and maybe there is potential we can implement this technology in Indonesia. As far as I know, in net zero emission target, according to the National Energy Commission, with a lower scenario, we need 35 gigawatt from nuclear power plant. Or according to the high scenario, we need 42 gigawatt. It means many NPP will be built by in Indonesian area, Indonesian territory. But I expect there are many technology we will use, large NPP or small NPP or even the micro NPP. But as usual, before we start the webinar, I would like to ask Professor Susilo Widodo to give his opening remarks. Please, Pak Susilo.
Terima kasih. Terima kasih, Prof. Jarod. Thank you very much. And good evening, everybody, especially our distinguished speaker from the Kepco, Korea, or KNE, Korea Nuclear Association, Dr. Sang Won Kim.
Yes, I can. Sorry, I little come late, so I cannot introduce that.
The team, Pak Susilo, with the team,
Yeah.
with 5%.
Okay, let me first speak in Indonesian. Bapak Ibu sekalian, selamat sore, selamat bertemu kembali. Salam sehat dari Pasar Jumat. Pertama, puji syukur kita panjatkan kehadirat Tuhan Yang Maha Esa, Allah Subhanahu Wa Taala, yang senantiasa memberikan rahmat-Nya kepada kita semua, karunia yang tak terhingga, sehingga sore ini pun kita bisa bertemu kembali dalam acara webinar Himpunan Masyarakat Nuklir Indonesia. Dan kali ini narasumber akan kami datangkan dari Korea, dan seperti sebagaimana yang telah disampaikan oleh Prof. Jarod di pendahuluan tadi, bahwa kita akan dicerahkan terkait dengan SMR, itu suatu jenis reaktor yang baru generasi 4, yang kebetulan namanya tadi apa ya Pak Jarod, BANDI ya, suatu reaktor yang Pak Bandi, ya, suatu reaktor yang dioperasikan di laut. Apakah ini floating atau nanti nempel di sebuah kapal besar dan bisa mensuplai energi tentu saja untuk daerah remote area, dan mungkin karena ini SMR, ukurannya juga tidak terlalu besar, barangkali energinya juga sekitar 60-an mega elektrik sampai 100-an lah gitu mungkin ukurannya, saya nggak tahu persis, tapi ya sekitar 100-an, sehingga kemungkinan penerapan seandainya bisa dibangun di Indonesia atau didatangkan ke Indonesia pun sangat praktis untuk daerah-daerah di luar Jawa, Bali yang jaringannya belum tersambung dengan rapi, sehingga mungkin daerah-daerah remote di Indonesia bisa tersuplai dengan energi semacam ini gitu. Dr. Sang-won Kim, thank you very much for your readiness to deliver the presentation today. I hope that this will bring the closer relationship between Indonesia and Korea, especially between Indonesian Nuclear Society and Korean Nuclear Association and other community in Korea, so that we can make the better communication, better cooperation, and close together in future. Because as maybe you heard that Indonesia also want start to build to operate nuclear power plant in future to replace some electric power supply using coal and oil, to remove them and replace with green energy, and one of the option is the nuclear energy, of course. So thank you very much, and I hope that all of us will enjoy with our your deliver speaking and discussion this evening. And well, my target is that the participant will reach 100, and this is almost 100, so that I will finish my speak and give opportunity to all of you to use this valuable time for us. Thank you very much. Selamat siang, selamat sore. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih, thank you Pak Profesor Susilo Widodo. Before we start the webinar, I would like to show you a short video to invite everyone in Indonesia to join the Indonesian Nuclear Society, or HIMNI. Okay, thank you. Let's run the webinar. Ladies and gentlemen, Indonesia is now in the process to construct, maybe I can say, some of the government's officers that I've met, they are very optimistic that we will soon have the nuclear power plant. Even the National Energy Commission's member, some of them said we will have the first nuclear power plant in 2032 with the power around 250 megawatt. Although I said this is very optimistic because 8 years from now, 2032 is not far away from now. 8 years, while regularly to build or the NPP, it takes time, maybe more than 8 years. But anyway, this is a good sign. In the last 2 years, every government officer, the leaders, political leaders, say that to reach the target of net zero emissions, we need nuclear power because we have to replace the coal power plant. Or what kind of power plant that we can use? One of the options is nuclear power. So today we are going to hear, to listen, and to learn the innovative technology from South Korea, from Korea. It is called SMR's BANDI. BANDI, just like Indonesian name. I don't know. Maybe later on, please explain to us what is the meaning of BANDI, the location name of the abbreviation. So the speakers today, although there are some members from Kepco NEC, Mr. Sang Won Kim. Mr. Sang Won Kim, I will read a short CV of him. His BS from the Mechanical Engineering, Sung Hyun Kwang University, and also the MS in 2017 from the same university in engineering. He started his career in LG Energy Solution in 2017 and was involved in a couple of battery development projects. Oh, it's very interesting. Then he started his engineering career in 2019 by moving to Kepco ENC. And he was also involving in the NPP project like APL 1000, APL 1400, and etc. Please, Mr. Kim, the time for you around 40 minutes. Thank you.
Thank you and good afternoon. I hope you had a great week, and it's a great honor to have this opportunity of being here as a speaker, as well as introducing Kepco ENC's SMR model, BANDI. So, can you see the presentation?
Yes.
Yes.
Yeah,
Okay.
that's good. Yeah.
Let me introduce myself briefly before moving on to the presentation. As you might have seen in my CV, I majored in mechanical engineering, and I'm currently working as a fluid system engineer in nuclear system supply system division of Kepco ENC. And my primary work is to perform thermal and hydraulic design and analysis for nuclear steam supply system in any type of nuclear power plants, ranging from conventional NPPs, PWRs, to SMRs. Well, that was about me, and let me begin the presentation. I'd like to introduce Kepco ENC's SMR BANDI for marine-based applications, which is being developed and I want to focus on the current status and challenges BANDI faces as we consider it as a marine-based application. And I guess some of you might have heard of our company, Kepco ENC, but for those who don't, I'll talk about Kepco ENC in the beginning. And I'd like to talk about the background, why we chose the concept design of BANDI for our own feature SMR model. And in number 3, I'll tell you the overall design concept and key design features of BANDI. And last, and we also will talk about technical challenges. And last, I'll end the presentation by discussing the future plan for BANDI. This diagram shows the brief structure of EPC consortium, so-called Team Korea. KHNP, Korean Hydro Nuclear Power, is a prime contractor, and each corporation takes part in plant O&M, nuclear fuel, and main equipment such as steam generator or reactor vessel and construction. And Kepco E&C is a key player of Team Korea that plays an important role in engineering, including architect engineering, BOP design, and nuclear steam supply system design. And Kepco E&C has over 45 years of engineering experience and offers a full scope of engineering services for nuclear power plants. And it is not only a designer of OPR 1000 and APR 1400, but also involved in Korean SMR projects as SMART and ISMR. And development of BANDI is also in the works based on our proven engineering technology and experience. I want to talk about SMR market and our choice for marine nuclear power systems. The economics of small reactor comes from the economy of mass production, which means that the bigger volume of production it has, the more profitable it becomes. The standardization of design is also important when it comes to mass production. So a big volume of work with a standardized design would be needed to make it competitive in the market. But we think it may be too optimistic to predict such a big market in the near future. So we thought that small reactors may be more suited for niche market if it could be used for these 3 applications on the screen. First, it'll be able to distribute power for a remote or isolated area where populations are scarcely distributed over a wide area. And it is also applicable to supply heat that's needed for various types of industrial processes instead of fossil fuels, fossil boilers. And it's also suited for marine-based power supplies. And there are 2 representative applications for marine-based uses. Floating nuclear power plants can supply power to remote or isolated island areas, and propulsion for bulky merchant ships also uses SMR as their propulsion power instead of diesel engines. As from 2030, potential SMR market size is expected to be over $100 billion and possibly grow even larger. Many competitors have already developed and preoccupied the market portions of SMRs. According to IAEA's SMR reports in 2022, there are over 80 types of SMRs that are being developed or have already been developed all over the world. And majority of them are PWRs, and they are all designed, most of them are designed for land-based application. And Korean major SMR projects such as SMART and ISMR are also aiming for land-based application. So what we have decided to focus on is a niche market and chose to develop marine-based SMR. In order to develop marine nuclear power system, we need to understand and continuously track the related policy changes. So International Maritime Organization, IMO for short, is currently spurring the set of goals for greenhouse gas reduction, and it aims to make 20% of greenhouse gas reduction by 2030 compared to the amount of emission in 2008, and 70% by 2040, and the complete net zero by 2050. But the amount of international shipping trades continues to increase, and the greenhouse gas emissions is accordingly expected to be increased by 3 times by 2050 compared to 2008. And in addition, merchant ships get bigger and faster these days. So the faster the ships are, the more the greenhouse gases emitted. So IMO's goal looks quite impossible. But anyways, this goal is somehow what IMO wants to reach in the near future. And therefore, we believe it cannot be reached without nuclear energy or SMR. Marine nuclear power systems could be applicable to 3 different types of applications. And the first one is gravity-based power generation and floating power plant ship propulsion. Floating power plants and nuclear ship propulsion based on SMR could be good business models. And the concept design of BANDI considers both of them, but floating power plant seems more feasible for near-term market because nuclear propulsion ships are mainly exposed to harsh oceanic environment, and this leads to the design requirement very difficult to be accomplished. However, most technologies are applied for marine-based nuclear power plant could be extended to be applied for nuclear propulsion ships in the near future. This chapter will give an introduction of BANDI, our SMR model, and I'll explain key design features of BANDI and our effort to collaborate with marine industry in Korea. We've been developing our SMR model brand BANDI since 2016, and BANDI is named after a tiny firefly in Korean, inspired from its clean and cute image of brightening up darkness by itself in a deep forest in a summer night. And our goal is to develop BANDI to provide and supply clean, safe, reliable, and affordable energy for remote area and water desalination and renewable energy backup and so on. And this is an imaginary picture of BANDI mounted on a large floating ship. And this picture is the overall configuration of reactor coolant system and safety systems of BANDI. And I will talk about this in detail from the next slide. This is overall configuration of RC reactor coolant system of conventional nuclear power plant and BANDI. So this is reactor vessel and pressurizer and steam generator and reactor coolant pump. And each of these components corresponds to the ones in BANDI respectively. And BANDI has some design features that make it distinctive from others. And the main features are categorized here into 10 features. BANDI has a block-type reactor coolant system, and I'll explain this on the next slide in detail. And moving on to soluble boron-free design feature, BANDI has soluble boron-free design that eliminates troublesome concerns caused by the soluble boron that we experienced in conventional PWR plants. And it significantly simplifies the chemical and volume control system, CBCS for short, and contributes to the reduction of the plant footprint. It also alleviates the corrosive environments and reduces liquid radioactive waste. And BANDI has CRDM, which stands for Control Rod Drive Mechanism, and it's installed inside the reactor vessel block. So we call it in-vessel CRDM. And for small reactors, especially for soluble boron-free SMRs, the control rod ejection accident becomes more serious than it is in bigger conventional reactors, since the reactivity of individual control rods is stronger. In-vessel CRDM eliminates the rod ejection accident from the design basis. And in conventional nuclear power plant, in-core instrumentation, ICI for short, is mounted at the bottom of RV, reactor vessel, but ICI is designed to locate on the top of reactor vessel in BANDI. And it has fully passive safety features, and I'll explain this in the later slides. And BANDI has canned motor RCPs, and these RCPs prevent all significant losses of reactor coolant inventory by eliminating RCP shaft seal leakage, which would otherwise result in a significant loss of reactor coolant inventory during a passive cooling situation with reactor coolant pumps not operating. And BANDI has an integrated pressurizer inside the steam generator block here. All these components and systems, including reactor coolant system and safety systems, are mounted inside the compact steel containment vessel. This is the CD containment vessel. And BANDI is expected to have a feature of automatic load following, which is just a concept for now. And we also have to consider the design conditions that could be obtained from marine environment that BANDI would be exposed to. Let's say, for example, motions of 6 degrees of freedom is one of the significant load factors to be analyzed. And this is what we are not very familiar with. So we are currently in collaboration with shipbuilding company and schools that are very renowned for this technology in Korea. And BANDI, let me explain block type in detail. And BANDI has so-called a block-type reactor coolant system, and it consists of one reactor vessel block and one steam generator block. These two blocks are nozzle to nozzle, connected to each other without large pipes, and designed in accordance with ASME PVC Section 3, Class 1 NB 3000. Upon compliance with this code, we can eliminate a large pipe break lookup, one of the most serious accident scenarios from the design basis. And compared to integral type SMRs, the block type SMR would be simpler and easier in surveillance and maintenance, and more proven in design and manufacturing, and more scalable in size. And when it comes to the flow circulation, reactor coolant flows up through the core in the reactor vessel block and picking up heat generated from fission reactions, and the hot coolant flow turns towards the reactor vessel outlet nozzle in the core exit plenum and runs into the steam generator block through the inner core axial flow path. And entering the steam generator block, it flows all the way upwards inside the long straight riser, and at the end of the riser, the coolant spreads across the steam generator upper plenum and then turns downwards through the heat transfer tubes here, transferring heat to the secondary feed water. And in the steam generator lower plenum, the coolant recovers driving force from the reactor coolant pumps here. Then it enters the reactor coolant block through the outer coaxial flow path, turns downwards to the downcomer and returns to the core. And steam generator is once through type with helical heat transfer tubes and produces superheated steam. The reactor coolant flows through the tube side, and secondary feed water flows through the shell side, the blue one here. And pressurizer is integrated into the upper head region of steam generator block and controls the reactor coolant system pressure using heaters and spray. And two canned motor RCPs are attached to the lower head of a steam generator block. This is the overall configuration of the reactor coolant system and steam safety systems of BANDI shown in this figure. And the reactor coolant system is enveloped steel containment vessel, CV for short, and the CV is submerged in the big containment vessel cooling tank, CVCT that's surrounding the CV and works as a heat sink in case of accident. And the CV also has a donut-shaped emergency core cooling tank. We call it ECCT, and it's open to the CV space in its dome. And instead of a separate core makeup tank, an extra volume of coolant is added to the upper head region of the reactor vessel block. And all safety functions of BANDI rely on the nature forces like gravity or buoyancy, which means it is fully passive for safety injection. residual core heat removal, and containment cooling, and so on. And in case of LOCA, core inventory is made up by gravity with the stored coolant in the dome of RV block. And if the level of our reactor coolant system decreases, or its pressure decreases, or the CV pressure increases, and they get to range out of the specified set points, the safety depressurization valves, which is called SDV, are automatically opened, and soon pressure balance is reached between the reactor coolant system and CV. Then cooling water is injected into the core by gravity from the ECCT in the CV dome. And steam and water discharged from, for example, from here, from the breakpoints, are cooled and condensed, and they're like condensed on the CV wall. And they after being condensed on the CV wall, they're collected in the bottom of annulus between the RV and CV. And heat from the CV is removed by being transferred to the CVCT through the CV wall by conduction. And the accumulated water level in the RV CV annulus rises above the safety recirculation valves, SRV, which are automatically opened at a specified set point. Then the reactor core gets flooded and is maintained in a long-term cooling mode by natural circulation. Simplification and optimization is being proceeded to make a design improvement, and there are a lot of feedbacks on the design to make it safer and perform better. And those feedbacks from safety and performance analysis always motivates us to get more focused on the detailed design. We have many proven experiences in designing nuclear power plants, but we still need collaborations with marine industry to make BANDI a perfect model as a floating SMR. There were MOUs last year and joint works for business models and economic feasibility and engineering between nuclear system and floating body are in progress. We are very challenged by some technical issues, and those are mostly coming from the concept of BANDI as a floating body. And because we consider BANDI as a floating nuclear power system, we have to concern ship motions excited by tide, wave, wind that are generated by the sea environment. And the motions are defined by 6 degrees of freedom of motions: surging, swaying, heaving, pitching, rolling, and yawing. And the displacement of each movement should be calculated and analyzed to be used as a load. And in addition, we also have to consider accidents that could happen to a floating body at sea. And we have to consider many cases when a floating body is overturned, sinking, or collides with something and bumps into the seabed, strands, wrecked, or tilted. So we're currently in collaboration with the building company and schools to develop a safety analysis tool with ship motions into consideration. And BANDI is mounted on a floating body, and because of that, it has a limited space and weight, and there is a mass and volume limitations for shielding materials, for personnel safety, and equipment integrity. So the system performance may have to be compromised. And besides, we have to consider the material integrity so that the material can endure the harsh oceanic environment. Other than the things to be considered as a floating body, load following capability should also be considered. And of course, the final goal of the development of marine-based nuclear power system is commercialization. But it is far to go. The development of marine-based SMRs all over the world is in an early stage, so there are many things to consider besides the technical issues. Safety concerns and security and safeguards across the territorial countries should be discussed. And the regulations are very different from those of land-based SMRs. And some of them are very hard to comply with, so international cooperation is necessary. This is the last but not least chapter, future plan. The first phase of the conceptual design of BANDI was started in 2016 and completed in 2022. And we have been through these design change in the first phase, and the second phase, including the conceptual design and basic design, just started in last year and will continue until 2028. And iterative works of system design and performance analysis will be carried out to optimize the reactor coolant system and safety systems. And to prepare for marine-based application, a lot of effort will be made to seek ways to comply with requirements and regulations of IMO. And of course, collaborations with marine shipbuilding industry will have to be further extended in the future. BANDI would be utilized for diverse purposes. A single or double modules could be mounted on a floating body and plays an important role as a floating nuclear power system. It will also be applicable to a way of propulsion system of merchant ships or containers, especially large ones. And still far to go, but there is a possibility of feasibility on SMR, renewable energy hybrid systems, such as VPP, virtual power plant. This is a brief roadmap of BANDI development project. And even though we have some technical challenges for now and many things to be settled, the overall process is currently on track, and some of the technical issues are directly related to the issues in SMART and ISMR. So BANDI can be a test platform for the other SMR projects in Korea. And it'll also be a good reference to these SMR projects once we will have established our own BANDI design. and we are proceeding forward to our goal with a lot of trials and valuable feedbacks. And we hope we could make it the standard design of BANDI and make it commercialized in the near future. That was all I wanted to discuss today. Thank you very much for listening to the presentation.
Thank you very much, Mr. Kim. It is very interesting, your presentation. And I will tell you, this name, BANDI, is very popular name in Indonesia. If you promote this SMR later on in 2030, because you said it will be commercialized in around 2030, maybe it is very popular. Oh, BANDI. BANDI is the Indonesian personal name, usually men. So, although the name, as you said, this is the firefly in Korean. Anyway, please, any questions from the audience? Mr. Kim allow us the question. Maybe some of the participants they have a background of technical background, or some of them do like ask you about the general issues. Hopefully, you can allow us to ask you, and you can answer that. But first, I would like to ask you in a general issue. There are a lot of idea of small and modular reactors in the world. But you said about around 80s, but only a few is already in operation. As far as I know, only 2 small modular reactors, like a floating power plant of the Russia, KLT-40S, and the Chinese HDRPM. So what do you think about that? Is there any obstacle or challenge why this is very difficult to, from the design, from the idea into implementations? Because this is very important question from us. Why? Because some of the decision makers here in Indonesia always ask us, what kind of SMR that we can use or we can construct in Indonesia? Because some of them believe that it is better to build smaller one rather than the large one for the first NPP. This is the question. The question is why only small options for the SMR, and what kind of obstacles or challenges? As engineer, maybe you know well about many challenges in this industry. Please, Mr. Kim.
I think that depends on the market. If you want bigger one, then you can supply. But the BANDI 60 is the basic design, standard design. So based on this standard design, you can increase the capacity or reduce the capacity. For example, the shipbuilding industry, they say 30 to 40 megawatt is sufficient for the merchant ship. So in that case, we can reduce the size. So it depends on the market demand. If you want bigger one, they can increase its capacity.
Okay, so maybe it means because for the first of its kind for the SMR, maybe economically expensive, for example. That's why, as you presented here in the map, there are many ideas, there are many development process of the SMR, but only few that is already in operation. Even one example in the Argentine, they are still constructing their carom, for example. So many years they need to implement that kind of technology. But hopefully for the BANDI, it will be faster. Then the questions for maybe for Indonesian side, no. I ask you another question is when you build for the first BANDI, if you build the first BANDI, you will operate by yourself for your Koreans need or demand, or you will export it to other countries?
I think that's also depends on the market.
Okay.
If you can operate the power plant by yourselves, then we can just sell it. But if you want operation, then we can also operate the plant. I think that depends on the market demand.
Okay. Sometimes this is the phenomena among the developing countries. Before we use it in our territory, we want the original country operate this NPP. So this is like a proven technology. It will convince the stakeholders for Indonesian, for example, in your country, in Korea, this technology is already in a good and safe in operation that convince everyone in Indonesia safety is okay, security is okay. That's why sometimes the requirement of that kind of it should be first operated or constructed in the original country. Sometimes there will be a requirement for that. What do you think about that?
Okay. As you know, in Korea, we have been developing small reactors that smart and ISMR and BANDI. We are asking the government that we should build the first small reactors in Korea. So based on that, we can sell the SMRs for the overseas market. So as you said, the original technology should be proven in the original country. So we are nowadays saying to the government that we should build prototype reactors, SMRs in Korea.
Okay. Yeah. I will explain it into bahasa Indonesia to the audience. Bapak Ibu sekalian, tadi saya bertanya terkait dengan slide ini kan banyak sekali ide tentang SMR ya, ada 80 yang dalam proses pengembangan. Tetapi yang sudah beroperasi itu mungkin hanya 2 saja, yaitu PLTN terapung Rusia, kemudian ada yang di Cina HTRPM namanya. Itu menjadi pertanyaan, banyak ide tetapi implementasinya menjadi tantangan. Waktu itu tadi juga sempat bertanya, tapi mungkin kalau dugaan saya biasanya pembiayaan cukup mahal di awal, karena ini first of its kind, jadi awal-awal biasanya biaya besar itu menyebabkan beberapa proses tertunda. Meskipun saya lihat ada beberapa yang sedang dibangun ya, seperti di Cina ada, di Kanada ada, Kanada itu BWRX, di Cina itu ACP 100. Tapi ini harus kita bisa menjawab ketika beberapa decision maker di pemerintah itu menginginkan pertamanya adalah SMR. Kalau DEN itu, Dewan Energi Nasional, 250 megawatt tahun 2032. Kemudian pertanyaan berikutnya tadi saya tanyakan adalah biasanya berbagai pihak di pemerintah itu inginnya ini sudah dibangun di negara asal sehingga itu meyakinkan pihak kita, oh ini aman selamat gitu. Itu menjadi tantangan. We have a history, the cooperation with the KRI in the past. In the early 2000s, we had a communication with the KRI, and the KRI promoted smart technology. At that time, we considered to use smart technology in Madura Island, a teeny island near Java Island, eastern part of Java Island. That was very interesting because not only for the electricity at that time, we wanted to solve the problem with the fresh water for the desalination. But the challenge, one of the challenges was at the time the acceptance from the public. At that time, many demonstration or anti-nuclear movement. That's why we canceled with the smart cooperation. This is outside the question of BANDI. What is the status of smart at the moment, right now? The cooperation with the Saudi Arabia and other countries.
I don't know exactly, but the Korea is they are trying to export their smart to the Canada. Yeah, they are talking with the Canada government. Actually, I don't know exactly where it is. There's the government there. There are some MOUs, and they're trying to apply the smart in Canada in those parts.
Oh, in Canada. Okay.
Yeah.
Oh, yeah. And there is no progress with the Saudi Arabia?
I don't know about that product. Yeah, sorry. Yeah.
Okay. Thank you. Thank you. Kalau Bapak Ibu ada mau bertanya langsung silahkan. If you have any question, please raise your hand. I have another question for you about the this BANDI. Do you have a timetable to use BANDI around 2030? According your timetable? Yeah, this one. It means conceptual design 2023, basic design 2025, and commercialization 2030, isn't it?
Yes, we share this roadmap with the shipbuilding industry, and then we will follow this roadmap, and that's our plan. But
Okay.
money is the problem. We need
Okay.
a lot of money to commercialize, and the technical things and also the commercial things that we need some big money. So we are talking with the shipbuilding industry then to make this build up the fund. But this is our dream.
Okay. But anyway, can I ask another question in that case? In your net zero emission target in Korea, your project electricity or energy projection, is there any possibility that you have to use this kind of BANDI technology?
In Korea is a small country, so we have many nuclear power plant, bigger size. So it's not, maybe the small ones may not feasible in Korea. It's a small country, so nowadays the renewable energies increases, and we also have a plan to build a big power plant, nuclear power plant. So unfortunately, we don't see the market in the near future with small ones in Korea?
There's some, actually, there's some, maybe some misunderstanding. Because we make a plan for the electric productivity every 2 years. We are now updating our new plans. Our government make a, I heard that they made a draft for new version. They try to incorporate the SMR in the one of the option of the electric production, but not exactly site is not decided yet. But one of the option SMR is it will be included in the electric production plan in the 2030, middle of 2030.
Land-based?
Yes, land-based. That's the must.
Yeah, I think this kind of technology is, well, this idea is good for us, the island country with the large territory like Indonesia. And that's why in the past we had communication with the Rosatom for adopting this KLT40S. But the challenge for us is many, including the politics or non-technical matters. But anyway, for us, for example, as I mentioned to you, that net zero emission target 2060, according to our projection, we will use at least 35 gigawatt from the nuclear power plant. It means more than 35 NPP with many technologies. I think this is a potential implementation in Indonesia. Anyway, there is one raised hand from Ibu Geni, Dr. Geni. Please, Bu Geni.
Okay, thank you very much, Pak Jarod, as a moderator, and thank you so much, Dr. Kim Sawong, regarding to your very interesting presentation. My question is about the you already mentioned about the recent status of the BANDI reactor. It is still in the conceptual design, and then in this roadmap you plan that the basic design we build another 2 years from now, yeah, and then you will license your design on your regulatory body. And my question is your regulatory body already has a fixed regulation for licensing the floating NPP? This is the first question. And then what is the specific aspect that they already modified for licensing your the floating NPP? And the third one is you listed in your PowerPoint that during the standard design and licensing in the 5 years, you will be commercialization. What the meaning of the commercialization? So this is still under this under the design. I mean, said on paper one, but it will be commercialization. So that's all of my 3 questions for you. Thank you so much.
Please, anyone responds these 3 questions?
제가 동의했어요. 첫 번째가 레귤러티 바디가 NPP 규제 요건을 준비했는지,
그러니까 그 중에 혹시 추가적인 규제 만약에 한다, 그 제가 잘 모르겠는데 실질적으로 어떤 규제 요건이 변경이 돼야 되는지. 그다음에 세 번째가 저 commercialization.
첫 번째는 그 플로팅 NPP에 대한 규제가
일본상 랜드베이스 주에서 한다고 얘기하죠.
As far as I know, our regulatory body doesn't have any concrete plan for the floating nuclear power plant, but still they are discussing the necessity of that kind of regulations. So we also discussing with the nuclear industry, and then shipbuilding industry together. And in the nuclear industry, we will talk with the Korean nuclear regulatory body, and also we have to talk with the ship classification companies. So we still don't know what kind of regulations in the seaside, so we have to discuss. That's the current status, frankly. So we are engineers, so we focus on, we think what kind of regulations we have to meet, but frankly, we don't know the exact regulations, what they need. So we are discussing these days with the regulatory body and the big industry, shipbuilding industry. And for the commercialization, we have to develop the business model first. And also, these days we are discussing with the shipbuilding industry what kind of business models are feasible. So, business model and the economic feasibility, the nuclear is feasible in the current market. We are giving the questions to the big shipbuilding industry. Also, they are asking that questions to us. So we have to discuss.
Okay, thank you.
Are there any questions? No?
Later.
Okay, thank you. Terima kasih, Bu Kenny. There is a question from the chat. This is very interesting. Maybe you have already mentioned. If accident happen, like sinking or something like, what do you think? What is your consideration about that? Because, well, accident happen frequently on the transportation using the ship, for example. Yes, like collision, sinking, capsizing. Is there any well, maybe we have to convince to the public if we want to use this kind of technology.
Yes.
Yeah, there is some accident kinds of thing, but shipbuilders said that their technology is very saturated. So they said they make build a barge or ship. They consider like a land-based. So their condition is almost same as land. So there is very hard to possible to collapse or that kind of thing. We don't need to consider that. They said the shipbuilder said that. Yeah.
The question is from the part one participants. Is there any possibility the radioactive materials released outside the ship and will contaminate the sea, for example? This is a general question, but this is very important.
Yes, we also consider that kind of the extent, but that's why we make the containment vessel. There's one of the characteristics of the SMR. So we make analyze and the assessment. There is a very low possibility to release of the radioactive material to the outside of the containment vessel. We need to prove it, and the regulatory body will verify that, validate our design.
Okay.
In the nuclear industry, when we develop new kind of reactor design, then we consider this kind of accident scenarios, and then we develop come up with the design requirement, come up to considering that kind of accident scenarios. So first, we have to clearly define the design requirement. Then our engineers can solve the problems anyway.
Okay, yeah. And another question from the audience about this is a marine nuclear power. It means you can use as a float nuclear power plant, or you can use on the barge. Which kind of this money for floating?
Floating?
I mean, there is one technology that promoted in Indonesia. I don't want to openly to say this vendors, but they are going to use like a barge. Then on the barge, they put the nuclear power plant. In your case, the BANDI case, you are using the coastal, is it, or something? It means floating nuclear power plant, isn't it?
Yeah.
Floating nuclear.
Yes, this is the typical example, the Russian model, the floating body, and two reactors are mounted on this floating body, and they supply electricity from here. Then this is an onshore, near shore nuclear power plant, and offshore. So we are thinking of this kind of business model. This is a typical one.
Okay. Yeah. Okay. So it means that the technology of BANDI, you choose the coastal power plant,
Yes.
one of the floating power plant. Okay, I understand.
And then there are cross-cutting technologies, a lot of technologies. So we can use this technique for the propulsion power engine for the big ship, merchant ships. So we focus this model, and then later we will diversify the applications to propulsion.
Okay, so thank you. Ada pertanyaan lain, Bapak Ibu sekalian? If you have any question? Well, some of the questions about, so this kind of BANDI technology can replace the conventional like fossil fuel in, well, for example, in a small island, in remote island, and that doesn't need the huge number of electricity, isn't it?
Yes.
Because this is the challenge for us.
Yes. And this is our we are looking at this kind of market, and what you said is just like this one, this kind of remote area and isolated areas, or yes, this kind of market. I think that's the very typical SMR market.
Okay. So the question is, when you have this kind of BANDI's idea, you put this, well, this is the view, the potential market in the world, for example. In your case, when you see Indonesia as a potential market, what do you see about maybe the remote, well, because we are archipelagos country, islands country, or maybe because there are potential market for the industrial to use this heat for the process, for example? or both? Let me tell you, let me explain to you. Some island in this country, they use the diesel power plant with maybe small numbers of the power of 50 megawatt or less than that. So the challenge for us is how to replace with other technologies. Maybe 60 megawatt is good, is suitable. But some other area, they need the heat for industries. So this is a good also the potential market in Indonesia. When you see this kind of potential market in Indonesia, what kind of your view of Indonesia as a potential to deploy the nuclear power, your nuclear power?
As I said before in the presentation, these three types of different applications are all possible, I guess, in Indonesia. Because as you said, BANDI as floating SMR can produce heat and supply heat to for the industrial process, and it definitely can distribute power for remote and isolated areas and island areas, and this is yes.
Oh.
And
No.
yeah, that's it. Yeah.
Okay. Well,
Yeah,
I
in
understand.
addition,
Because I remember when the French company
yes, in addition,
called FlexBlue came to us. Maybe you know FlexBlue. FlexBlue
yes,
is a company that they have experience to build the submarine. Then they are coming to us promoting, oh, this is suitable for you because you have a lot of islands. Then you can use this kind of technology. We can use this FlexBlue in the base of the sea. Then we'll supply the island for a long time, for example. So, but I expect or I can imagine that this kind of demand is high in Indonesia for remote island, and also this kind of BANDI technology for the industrial need is also a good potential market, I think.
for example, in addition, you mentioned when we started to consider this kind of market like remote islands,
Yeah.
it begins at 2018. I think you have seen in the presentation material. So it's like SMART. SMART also is considering small remoted island, remoted territory, like some part of gas cannot be provided, small islands with target. And BANDI also consider the same market as SMART. And we are considering to commercialize, to get real as a first, in 2030, mid-2030, we think it would be commercialized in that time period. So we consider around 2016-18 after SMART has been developed. And you also made a question about SMART. Kepco also have joint SMART project with Kerry already since 2010, I think, maybe more longer than that. And we have developed, I think, invest more than, I don't get the number exactly, but we have not developed, we have joined the design also. So most of it, I think it's the BOP part.
Yeah.
I think it's not the primary part. I think it's the secondary part. We have participate in that design, and that evolved to ISMR and other SMR technology. And also, BANDI is one of our SMR models that Kepco ENC is developing.
Okay. Thank you. Thank you very much.
Yes, yes.
Jenny, do you have any question?
Yes, thank you so much for your explanation. I will continue Pak Jarod question about the cogeneration. My first question is, what is the philosophy of Korea design the floating system? It looks like Russia. Russia designed some floating system like rhythms and etc. because they will use the electric product. They will use the electric for mining or something like that. And then in this case, why do you design the BANDI as a floating system? So where the location that you will be implemented for BANDI for the first time in the Korea? This is my first question. And the second question, you already mentioned also that the BANDI can be a cogeneration and PPE. What do you mean cogeneration itself? We can use the electricity for other cogeneration on non-electric application, or we can use also the heat which is coming from the reactor itself as a cogeneration. And the third one is how is the design life of the BANDI? Thank you.
Last question is simple. 60 years.
50, 1 5.
60 years. 60 years.
60.
Okay.
60.
60.
60. Oh,
Yeah.
60. Okay.
Yes, yeah.
And then the other question,
Yes.
yes, about the
So-
location, the first location that you will implement the BANDI as the first NPP, floating NPP in Korea. Is there any other philosophy why you designed the BANDI? Looks
Yeah.
like Russia, yeah, for mining, something like that.
Our primary target is the overseas market.
Okay.
export. So, as Mr. Kim presented, we focused on, we have been interested in the SMR about 10 years ago. And they say the SMR is they have big potential in the near future, but already on the land basis SMRs, they have a lot of competitors already so we have to choose the other areas. That's the kind of niche market. That's the marine-based application is we chose that market. That's why we are developing the floating nuclear power plant. And we are looking at the overseas market, not Korean market.
Okay.
But it's a still idea, it's not planned. But the steel company in Korea, they are located in the near the ocean. See, so they want their own SMR. So and the one of the option is floating is possible, but the public acceptance and law is very many obstacles. But steel company want our floating SMR, and they are interested in.
Okay. So you will not build and operate the first BANDI as a demo plant first in Korea? No.
Actually, we don't have plan yet, but
Okay.
yeah.
So you don't have any plan to build the demo plant on your country first to prove that
We
the
will try,
BANDI is
we will
good,
try.
yeah, the BANDI is safe, etc.
Yes, it's very important. Yeah, I just said the product technology is very important. So we are trying to cooperate with our government, but we didn't have plan yet.
Okay.
Yeah. Any questions? Bugeni? No?
Another one. Even this is still in under the basic design, I'm very sure that you already have a plan. How is the cycle of the fuel that you design on for your Bandi? Maybe 1.5 year or 3 years or something like
5
that?
years. 5 years.
5 years, okay.
Yes.
Okay, terima kasih. Thank you, Bugeni. I
Yeah.
have a question for the fuel cycle. For example, this is if we buy the Bandi, then we use it, we operate in Indonesia. So all of the, well, some of the idea of the technology of floating power plant is after some time, for example, 2 or 3 years, then when you want to refresh the fuel, the ships go back to the original country, then they change the fuel, then go back again to Indonesia, for example. Is that this kind of scenario? Or we should supply by ourselves? And the second is about the radioactive waste. What, it means that radioactive waste should be managed or disposed in the territory that, for example, in Indonesia, or maybe it will be taken back by into Korea, for example. This is sorry, the silly question.
해결료 교체는 어디서 할 건지가 첫 번째. 두 번째는 해결료 처리는 어떻게 할 예정?
The spent fuel, that's a very difficult question. And I understand the Russian models is they take all the spent fuel to their country, so they replace the fuel and then just that they call it the green loan business model. So I think that's the very difficult question. Then also depends on your demand. What depends on what you want. So
Okay.
we have to discuss.
Thank you. Well, anyway, because some country when came to us in the past, for example, a certain country, well, you can use this kind of technology, and I will take it back to spent fuel, for example, or on the case of floating or submarine, they said, oh, you can use this power plant then for the refreshing the fuel. The ship will go back to the original country, then they change the fuel, then go back to the Indonesia. This is just only an example, but I agree with you that it depends on the contract business that we can do in the future.
Let's discuss.
Yeah. Okay. Well, anyway, it's very interesting because sometimes the question from the decision makers, from the government, they don't have the background of nuclear technology. The question is, their first question is the price. Let me give you the secret of our government. They will ask you if you have already got license from your authority, regulatory authority. If the government delegation come to you, to Kepco, then they will ask the price. How much?
Price.
In this case, you don't have any imagination in this moment. But anyway, this is the first. The second is, can you prove it? This is very safe. That's why Dr. Kenny mentioned about if you can build in your own in Korea, you operate it, then the government of Indonesia, oh, that's good. It's already safe. Convince us about the safety. But anyway, because you mentioned this is the for the export market. I can understand the situation. The third one, usually the government would like to ask you the power, but you already mentioned 60 megawatt. Then you can double or triple into 120 or more. But for the closing remarks, because it's already nearly 5:30 Jakarta time, if you have any closing remarks, or maybe what do you want to say about more for the future cooperation, potential cooperation, please, anything you want to say for the closing remarks.
Actually, we are working with the shipbuilder, HD Hyundai, and we are expand the cooperation with the HD Hyundai and the shipbuilder, ship classification company. And actually, it's ABS, American Road Shipbuilder here. So we are looking for the partner, like an Indonesian. There, we want to make a more visible process. We want to make a develop together business model and very good customer aspect careful and regulation. And so we're looking for the partners. So if you have interest in the join this program, please contact with through KNA or through directly connected to our company. So we're gonna very soon, maybe next month or within a few months, we're gonna make launch the new development program with HD. So please join the program.
Okay, thank you very much. Well, this is very interesting webinar because the audience in the peak moment we reaching the 280 participants. This is very good to disseminate the nuclear technology, nuclear power technology. But anyway, because I'm and other colleagues working for the National Research and Innovation Agency of BRIN or Indonesia BRIN, then I will deliver this opportunity to open the cooperation between Kepco and our agency in the government, whether, for example, to cooperate on the this is a kind of cooperation. Is this technology is suitable for us in some island, a certain island, for example? Because again, net zero emission target without nuclear is impossible. This is the declaration of the government of Indonesia. It means we need many technology, not only one or two, not only large reactor, but also the small modular reactor, and of course the micro reactor. Again, thank you very much for the Kepco ENC teams. Thank you, Dr. Song Kim and others. Hopefully we can still communicate, and hopefully, well, I will ask you many about this BANDI. Again, BANDI is a good name. If you want to promote this name to Indonesia, maybe become one of the most popular nuclear technology in Indonesia. Again, thank you very much. See you next time. Thank you.
Thank you.
Thank you. Bapak Ibu sekalian, demikian pertemuan kita hari ini. Kita akan bertemu kembali hari Kamis depan dengan topik yang berbeda. We will see you next Thursday with another topics, different topics from the BANDI. But anyway, hopefully you can still enjoy. Harapan kami tetap bisa bergabung dengan webinar ini. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih. Thank you very much. Thank you. Terima kasih.
Salam, terima kasih Pak Jarot.
Terima kasih. Thank you.
Terima kasih Pak.
Yuk, sami-sami. Saya tutup ya.